Okay, so we're going to learn all about a type of conic section called hyperbolas in this screencast. And here's the fancy mathematical definition. A hyperbola is a set of all points x, y in a plane, the difference of whose distances from two fixed points, called foci, is a positive constant. What does that mean? Well, let's get a set of axes here. And let's say that I've got my two foci, one there and one there. Then the hyperbola is this pair of curves coming around here. And their characteristic is such that if I pick a random point on that hyperbola, x comma y, and I measure the distance from that point to one focus and subtract the distance from that point to the other focus, I'm going to get a positive constant. And it doesn't matter where I am on the hyperbola. So if I pick another random point down here and I take that distance minus that, I'm going to get exactly the same constant. And so if I collect all these points together, they form what's called a hyperbola. Now both of these curves together make up one hyperbola, and they are not two parabolas trying to have a collision. It's totally different from a parabola. Okay, now what kind of equation gives us a hyperbola? Well, the standard form of the equation of hyperbola with center at hk is x minus h squared over a squared minus y minus k squared over b squared equals 1. If you've studied ellipses, that looks familiar, except instead of a plus, you've got a minus in the middle. Okay? Now, for this form of the equation, the transverse axis is horizontal. How am I going to tell that apart from one where it's vertical? Well, if the x is positive, if the x squared part is positive and the y squared is being subtracted, that means your transverse axis is horizontal. Okay? So, how do all these parts fit together? Well, let's say that our center is just randomly right there, HK. Okay? I'm going to go horizontally A to the left and A to the right. So that's negative A there, and that's A there. And then I'm going to go vertically B up and B down. So that's B. And then I draw a rectangular box that contains those points. And then I draw asymptotes that connect the corners of my box and go right through the center. And since the transverse axis is horizontal, that means my asymptotes, I tell you what, let's do that in blue so we can tell it apart, okay? The hyperbola looks like this. It does not touch the asymptotes, it approaches it. The hyperbola does not touch the center. The center is right there, but that's not part of the actual hyperbola. Here's the hyperbola right here. So what about the foci? Well, c squared is equal to a squared plus b squared. So I figure out what a is, I figure out what b is, and I put c at the appropriate place on the left and the right. So that's where they all fit together. Okay. Now, if I have y squared being minus something x squared, that means that my transverse axis is vertical. And everything works pretty much the same way, except that our hyperbola will be going like this. So I would go to a random point hk right there. Now, since a squared is underneath y squared, I'm going to go up a and down a. I'm going to go to the left b and to the right b. I'll quickly draw in my asymptotes. And this time I'll draw the hyperbola in green. And since the transverse axis is vertical, it's going to go like that. Notice that I'm just kind of eyeballing it, okay? I'm not getting any specific points except the vertices, which are these points right here. Those are the vertices. And then c squared equals a squared plus b squared, so c would be somewhere there. and somewhere there. Okay, those are my two foci. All right, so if the center of the hyperbola is at the origin, then your k and your h go to 0, and you get nice simple equations right here, like that and like that. Here x is the positive term, so this would be horizontal. Here y is the positive term, so that would be vertical. All right, what if we want to know the equations of the asymptotes? Well, if the hyperbola has a horizontal transverse axis, remember if your x squared term is the positive one, then you have y equals k plus or minus b over a x minus h. If it has a vertical transverse axis, then the slope switches from b over a to a over b. Everything else is exactly the same. So you need to remember these two equations for asymptotes of a hyperbola. Eccentricity of a hyperbola. Well, if we know c and we know a, we just get the ratio, and that's our eccentricity. E equals c over a, which is the same ratio as the eccentricity of an ellipse. But a is always going to be smaller than c for a hyperbola. So that means that the eccentricity of a hyperbola is always greater than 1. So as a matter of fact, we can classify conics based on their eccentricity. If the eccentricity is 0, then we have a circle. If it's between 0 and 1, we have an ellipse. And if it's equal to 1, it's a parabola. Let's do some examples with numbers, okay? So we're going to find the center, vertices, foci, and the equations of the asymptotes of the hyperbola. And finally, after that, we're going to sketch its graph. So to get started, I'm going to group the x terms together. And I'm going to leave a space and group the y terms together. Actually, let's factor out a negative, okay? And that's, I'm messing up, aren't I? That should be 25. And this is 9y squared. And I'm factoring out a negative, so that's going to make that a negative 54y. Leave a space, and we'll put the constant over there by itself, okay? And let's factor out a 25. And factor out a 9. Equals negative 94. And we're going to complete the square. So I'm going to take half of 8, 4, square it, 16, and add that to both sides. So I get 25 times 16. I'm adding a 400 over here. Now I'm going to take half of 6, 3, square it, 9. I'm adding a 9 times negative 9, which is negative 81. And all of this, believe it or not, equals 225. So here's what we have. 25 times x minus 4 squared minus 9 times y minus 3 squared equals 225. And you'll notice in our standard form of an equation, it's always equal to 1. So, back to our problem, we're going to divide everything by 225 to make it equal to 1. And 25 goes into 225 9 times. And that means 9 goes into 225 25 times. That worked out nice because I planned it that way. Okay, so do we know our center? Yes, we do. Our center is at positive 4, positive 3. A is 3, B is 5. So I'm going to go to my point 4, 3. And since x is the positive term, we have a horizontal transverse axis. So I'm going to go 3 to the right. I'm going to go 3 to the left. I'm going to go 5 down. I'm going to go 1, 2, 3, 4, 5 up. I'm going to fill in those points into a rectangular box. I'm going to plot my asymptotes by connecting the corners of that box. And on a transverse horizontal axis, my hyperbola looks like this. Okay, here's one vertex. It is at 7, 3. And here's another vertex. It is at 1, 3. How about the foci? Well, c squared equals a squared plus b squared, which is 34. So c is plus or minus the square root of 34, which is a little less than 6. So from the center, I'm going to go out a little less than 6. 1, 2, 3, 4, 5, 6. So I'm going to put one focus right there. And then go back a little less than 6. 1, 2, 3, 4, 5. Right about there. And there's another focus. Okay, so technically, my foci are at 4 plus or minus the square root of 34, comma 3. Equations of the asymptotes. Okay, that's going to be in the form of y equals k plus or minus b over a times x minus h. So that's going to be 3 plus or minus 5/3 x minus 4. And that's it for that problem. So what happens if we don't know the equation but we know some information about the hyperbola? Well, here we've got one whose vertices are at negative 2, 1 and positive 2, 1, which lets us figure out right away that the center is the midpoint between them at 0, 1. And that means that A is 2. And that means that our transverse axis is horizontal. So I have x squared over 2 squared minus y squared, not y squared, y minus 1 squared over b squared equals 1. How can we get b? Well, the foci are at negative 3, 1. See, our hyperbola is doing this, right? And positive 3, 1, which means that c is 3. So c squared equals a squared plus b squared, which means 9 is 4 plus b squared, which means b squared is 5. And now we're ready to write our equation. X minus 0 squared over 4 minus y minus 1 squared over 5 equals 1. And that equation will draw the hyperbola with those characteristics.